The goal with this video is to list all subnet IDs of a Class A, B, or C network. And there are really 4 videos that go together, and this one begins the process by showing a very simple case, a Class B network with a /24 mask. Along the way, I'll keep building the story of how to go about doing this so that you'll be able to handle the more complex cases. Ready to get started? Let's go. So this topic happens to match up with the Volume 1 official Cert guide and the last chapter in Part 4. And in that chapter, there are 2 sections. The first of them revisits this whole design idea of if you take one network and choose one mask, that mask meets requirements for a number of subnets and hosts. But once you've done that, that one mask then allows you to calculate and figure out what are all the subnet IDs that you've created. And that's what this video and others in the series related to it let you do. So this video is the first of 4, and this one handles one simple case using a Class B network where there are exactly 8 subnet bits. So I'll go over the generic process to begin, and I'm going to do that in each video of these 4. I'll go over the generic process, and then I'll show you how to use the generic process for this one specific simpler case with a Class B network with 8 subnet bits, which means we're using a mask of /24. So just to emphasize, in this series of related videos, we'll have this one, which is for one easy case, the next one for a second easy case, a Class A network with the /16 mask, as it turns out. Then this more general case, which is the one that's most important for exam prep. And then finally, a final video in this series that's more about the more obscure cases. All right, as usual, hang around to the end of the video. I'll give you some advice about when and how to review both here at the channel and in the books. All right, let's jump in with this first simpler case. I'll start by describing the process generically, regardless of whether the case is a simple case or a more complex case. The goal is to find all the subnet IDs. So you make a list, and the subnet IDs are of one classful network, one Class A, B, or C network, and we're assuming one mask only. That is, we're not using VLSM. Now, the process I describe here, I don't care if you memorize it forever. It is a means to an end. What I want you to do with this process is see the numeric patterns, so that over time, with practice, you'll get to the point where you see a network and you see the one mask that's used, and you'll immediately see the pattern. You'll see that all subnet IDs increment by 8 or 16 or 32 or whatever, and mentally see the subnets, and it's not a big deal, and you won't remember the scaffolding I put around the process to make it work and help you learn it, all right? So here's the process. You first identify the address structure as network, subnet, and host parts. That's a classful view of the address structure that we've talked about many times in this subnetting section. Then you write down the, quote, 0 subnet. I'll define that in just a second. That's always the first subnet in the list. It's the numerically lowest subnet of a network. And then to get the next subnet, you calculate it based by adding a little bit to the number of the previous subnet. And you repeat that, and you add a little bit to get the next one, you add a little to get the next one, and the next one, and the next one. The only problem then is you have to figure out when to stop. So to figure out when to stop, you stop with the broadcast subnet, and I'll show you a way to identify when you're at the end of the list. So to reiterate some assumptions, we're subnetting one Class A, B, or C network, and we're using one and only one mask to subnet the network. To begin this process, you have to do a classful analysis of the address structure. So we've talked about that repeatedly throughout this subnetting section about how to do that. But once you figure out the number of network and subnet and host bits, and if you think about your list of all the subnet IDs, here's an interesting fact. The network part remains the same. That is, all the subnets of a network have the same value in the network octets. All right, that shouldn't be a surprise, but there you go. In the host part, that stays the same as well. So that's static, that's static. The part that varies from subnet to subnet is the subnet part of the address structure. Basically, you're numbering subnets with different values in the subnet part of the address structure. Now, in this particular limited case, where we're subnetting a Class B network, we'll have 16 network bits based on Class B rules. That is, the whole first 2 octets are network octets. And with the /24 mask, it means we've got 8 host bits. And that means we'll have 8 subnet bits. So in this particular design, the structure gives us 8 subnet bits as the third octet. Only the third octet's value is going to change from subnet ID to subnet ID. And I'll show you an example of that. Now, the next part of the process said to begin by writing down the quote 0 subnet. Now, that is a term that you'll need to know. And here's the deal. If you can figure out the network ID, which you're probably given, say, on a test, or you're given in the context of you work at a place and we know what network we're subnetting. The number, that is the class A, B, or C network ID, is always the same number as your first subnet, and that subnet is called the 0 subnet. So you just write that down as your first subnet ID. Now you might wonder, that's a strange word for it. 0 subnet, what is the deal? Well, if you were to look at the binary value and look at the subnet bits, all the subnet bits have a binary value of all zeros, and that's what the term 0 subnet comes from. So just a few facts about the 0 subnet. Every subnetted classful network has one 0 subnet. Formally, it's got all those binary zeros in the subnet part. Numerically, it's the numerically lowest subnet ID in your list of subnet IDs, so it's a place to start. And the subnet ID, the way you find it, the subnet ID is equal to the classful network ID. The generic process builds on this 0 subnet by writing the next subnet ID, and then the next one, and then the next one, and so on. Now, you may recall that in each successive subnet ID, the network part is a copy of the original subnet ID. So we're just copy in the network part. The host part is also a copy, copy. And it's only the subnet part that changes. So what do we change it with? Well, we change it by adding the quote magic number. And I'm going to show you how to calculate the magic number. It'll be different depending on the mask, right? So if you've got a different mask, well, we're going to have a different magic number. And so we add the magic number. And that's really the pattern that I'm wanting you to learn to recognize by doing practice problems with this process. And so we keep doing that, and we add things up, and we get the next and the next and the next subnet ID. And eventually you're going to write down the last subnet ID in the list. And that one also has a special name. The last one, the numerically highest subnet ID, is the broadcast subnet. Now, warning here. I'm not saying broadcast address in the subnet or subnet broadcast address. This is a different term, weirdly enough. This is the broadcast subnet. So this is the numerically highest subnet ID, and that's what the term is defined as. So the last subnet ID, if you will. So how do you recognize it? Well, when I start showing you examples of the process, I'm going to show you how to recognize the broadcast subnet and then stop writing new subnet IDs down. All right. So last bit, when you start to make your list, it's nice to set up your workspace like this. In this case, I'm going to show you an example with a Class B network, 2 network octets. So I make my space for the network octets 2 octets wide. 1 subnet octet, so a little bit skinnier here, and 1 host octet, so a little bit skinnier here. So I'm implying with my workspace that I've got 2 octets worth of width here, just to emphasize what goes where, just to keep things column aligned and make it easier to work on the math problem. All right, next up, we'll talk about an example of using that process. By the way, when you are thinking about buying my books, any other books, or anything else for that matter, if you'll start with this QR code or my link tree and buy from there, you don't have to pay anything more, but those sellers will give me a small affiliate marketing credit. It's a great way to say thanks and support the channel. All right, let's get back to the content. So let's do an example. It says Class B network with a /24 mask, and specifically it's network 172.16.0.0, and I've rewritten the mask in dotted decimal notation, 255.255.0, and I'll leave this over here on the upper left of the screen for the next many slides, all right? So we're going to start out by doing our classful analysis, that is, figure out the number of network, subnet, and host bits. Well, we're subnetting a Class B network, so we know by definition it's got 16 network bits. There they are. Now that means the whole entirety of the first 2 octets are network bits, so I'm going to treat those as network octets for my process. Next up, how many host bits are there? Well, there are 8 zeros in the mask. They're on the far right. So all 8 of the bits in the 4th octet are host bits. I'll call that the host octet. And then the leftover bits in the middle are subnet bits. All 8 bits in the 3rd octet are subnet bits. So we'll call that the subnet octet, all right, in this particular case. So after that bit of analysis, I'll set up a place to record my subnet IDs, and I'll make sure it's a little bit wider under the network octet column, 2 octets wide, because I've got 2 network octets, 1 octet wide under subnet and host octets. So here's where I'm going to write my list of subnet IDs down. I'm going to start the list with the same number as the network ID itself. Well, we're subnetting network 172.16.0.0, and I write that down. Why? Because that's always the same number as the 0 subnet. So that's a pretty easy start. Now, once you do that, you can go ahead and copy 3 of the 4 octets into your list, because the network octets are all going to be the same value as the original, and the host octets are all going to be the same value. The mystery then is, what values do you use in here in the subnet octet? So that's what we'll spend the next few minutes figuring out. Well, it turns out that we add 1 to each successive subnet ID in the subnet octet to get the next subnet ID. And we stop with this last value that's got a 255 in the subnet octet. So let's develop that, and let me tell you why you do that instead of just telling you that you do that. Well, first off, the magic number, the number you would add, is calculated by starting with 256, always 256, and subtracting the mask's value in that octet. Now in this case, the mask's value in the 3rd octet is 255, so you get a 1. And showing you that a little bit differently in a slide, if I line it up, network octet, here's the subnet octet, and I have the mask value here, 255. Well, 256 minus 255 is 1. Again, our magic number in the 3rd octet in this case is 1. If it's a different mask, it's going to be a different magic number, all right? But in this case, the magic number is 1. So you start with the 0 subnet, you add the magic number in the subnet octet to get 1, to get 2, to get 3, to get 4, to get 5, all the way up to 255. All right, so that's how you come up with the list of subnet IDs. And I go to the effort to show you this generic process applied to this one simpler example to help you learn the process, so when we get to the trickier examples in subsequent videos, it's a little clearer for those trickier examples. But how do I know to stop with that one that's got a 255 in it? Well, there are a couple of ways you can know to stop. Here's my personal favorite, so it's the one I'll describe. You may recall that in an octet of a dotted decimal number used with IP, the values range from 0 through 255. Those are the only legal numbers. Well, if you kept adding here in this 3rd octet, you'd eventually add to get to 256. So whenever you do the addition and you'd say, hey, the next one's got a 256 in it, that should trigger a, hey, that seems like it's illegal, and it is. So you can even write it down and put a line through it and say, well, the one before it, that's got to be the last one in the list. It is, it will be, and that's the broadcast subnet for that design. All right, so that's your process as applied to that one Class B network with that one mask. In the simple case, this is a reference for you. It's the final written instructions. You start with the 0 subnet that's equal to the network ID. To create each successive one, you copy the network part and the host part, but add the magic number in the subnet part, and you stop with the broadcast subnet. And you recognize that by noticing that you would have written the 256. Stop, don't use that one. The previous one is the broadcast subnet. All right, study group folks, if you've got the books and you're following along, we're in the current edition, volume 1, chapter 15, in section 2, and it's about finding all subnet IDs, and I've broken the content in the book into multiple matching videos here. And the goal, though, I have for you is to learn how to find and use that pattern, the videos, and the process are a means to an end, as I mentioned earlier. You should just keep watching the successive videos at this point, honestly. I could have you go back and look at the chapter at this point, but I think it's better to watch the videos in sequence and then use other resources. So of the 4 related instructional videos, just keep rolling. You just finished the first one with an easy case, do the next one that's class A with a /16 mask, and then do this third one, which really is the core of what you need to know to be exam ready, where the fourth one goes into the more unusual cases. All right, so keep it rolling. Once you do get through with all of those, it's probably worth a skim at least, if not a read of the matching section in the chapter. All right, other than that, keep rolling with the videos. So if you are indeed ready for that next video in sequence, click on the left and you'll see that class A case with a /16 mask. On the right, if you're like, hey, I don't need that one, I just want to get to the less than 8 subnet bits, the trickier cases, the part that you need for being exam ready, click on the right and move on up to that one. Hey, thanks for taking the time. I'll see you in the next video.